this week, Wednesday, Thursday. Oh, test 5 is the last day of that last week, that Thursday. I think that's the 2nd or the 1st. Because August 3rd is the last day of the semester. And I think that falls on a Saturday. So, in fact, I can look right now. Yeah, it'll be August 1st, your test 5. Okay. All right, for your test tomorrow, I put this study guide together last week, and it's still valid. You'll have, I also posted a practice test. I'm going to go over that today. Make sure you know these. Avogadro's number, 602 times 10 to the 22nd. Make sure you know that. 22.4 liters per mole at standard temperature pressure. 2 equations for gases, PV is equal to nRT, and then PV initial over NT is equal to PV final over NT. R value is 0.0821. Gas units are, for that R value, is atoms, liters, Kelvin. And the relationship between Celsius and Kelvin is 273. Kelvin is always more. Always more. It's always more by 273. And that's absolute zero. Okay? And the practice test pretty much has a practice problem for each one of those. Now, what you're going to get on the test is a periodic table, solubility table, and also page 1 of lab 7 for the activity series. Because you'll need that for your single replacement. Okay, so are any questions so far regarding anything? I was not doing so well this weekend. I was not feeling well, so I didn't get a whole lot of schoolwork done. That's why I was Saturday before I got the practice test done, not Friday. Lab, some of you reposted labs, and I still have your emails on that, so don't worry, that's to be done. Okay. All tests, make sure sig figs are adhered to. Show your work as much as possible. All the tests are worth 100 points, as I convert all raw points to percentage points. Okay, so I just told my daughter about my friend. She knew him really well as well. She's been nonstop texting me about it. So that's what the clicking's about. Okay, how many grams are 3.45 moles of water? How much does it weigh? Okay, so what's given? What's given again? Moles. We're trying to calculate grams. What conversion factor has both moles and grams in it? Molar mass. And that value comes from the periodic table. 2 hydrogens and an oxygen, 1802 grams per mole. Moles cancel. Now that's going to be the easiest problem on this test. Okay, how many oxygen atoms are in 1.23 grams of C2H6O? Now, looking at the formula now, if I have one molecule of ethanol, which that's drinking alcohol, how many oxygens do I have? What's the ratio of oxygens per molecule? It's like a bicycle. You got 10 bicycles. How many seats do I have? 10 bicycles. How many seats? 10. And the ratio is 1 to 1, right? Look at this ethanol molecule. We have one molecule of ethanol. How many atoms of oxygen are there? 1. So it's 1 to 1 ratio. So if I can calculate the molecules, I can automatically know the oxygen, but we have to put the conversion factor in. Otherwise, it's not, you're going to lose points on setup. Okay, so we're starting with the intermediate unit, which is moles. So we need to find out how many moles, how many grams are in 1 mole of ethanol. So that's 2 carbons, 6 oxygens, and 1 oxygen. Okay, so that's what, let's see, O2, 28, 29. Okay, so that gives us moles. Now we need to go to the number of molecules, Avogadro's number. And then lastly, we have to have that 1 to 1 conversion factor in there. Otherwise, your units don't cancel out. Okay, everyone understand why I had to put the 1 over 1? Does nothing numerically. It's for unit cancellation. And it's got to be there for proper setup. Okay, we're converting 1.23 times 10 to the 15th molecules of water. How much does that weigh? I'm sorry. The 602? Oh, yeah. You're talking about, yeah. Balance following chemical reaction. Okay, we have a reaction here. Is this a single or double replacement reaction? Okay. Salt and salt. Double or single? Double. For single, you have to have a metal and a salt. Okay. So first thing, we're going to swap the cations. So the lead goes to the right, the potassium goes to the left. Now the lead forms a +2 charge. That means we have to have 2 chlorines -1 apiece. So I have to have 2 of them. Okay, potassium's +1, nitrate is -1. Okay, so is it balanced? Not balanced. Okay, so first of all, we have 2 potassiums on the right. Right now we only have 1 on the So let's put a 2 here to make sure we have 2 potassiums. What about nitrates? Here we got 2 on the left. How many on the right? 2. So we have 1 molecule here, but there's 2 molecules once we balanced out the potassium. Excuse me. Now the next question is there a solid formed? So what you're going to do is you're going to look on this here. And we're looking for lead on the top. Okay, here is lead right over here. Okay, we're going to go down to chloride, and it's black. So that means we're going to get a lead chloride solid or precipitate. Does everyone see why getting a lead chloride solid? Because the intersection is black. So instead of AQ, this needs to be S for solid. Okay, so that's the molecular equation. It's not the total ionic. Remember, total ionic, we pull everything apart. This is the molecular equation. Okay, the net ionic. Did something happen? It did. We formed a solid. So that means we have a net ionic equation. That's what the lead plus a chloride yields so that's the net. And what are the spectator ions? Okay, there's nitrate and potassium. Those do nothing. They just are carried along for the ride. Now your test tomorrow is going to look very, very similar to this. Same length, same problem sets. Okay, are there any questions about how I got any of that? So double replacement, we swap out the cations or swap out the anions, doesn't matter which one. We swap out one set of them. Okay, so here we have, let me go back, one other comment here. So this is salt, salt. That's double the salts. Think of that. A salt is a cation and an anion. And you have to have for every salt AQ. Okay, zinc is a solid or a metal. So here we have metal, salt. So single replacement reactions, the metal goes to the salt goes to the metal. So in other words, the zinc and the lead here swap places. Salt below goes. That expression will tell you whether this reaction is going to react or not. Okay, So let's look at the activity series. So we're looking at zinc and lead. Okay, so here's lead and here's zinc. So which one of those two is the salt, the lead or the zinc? Lead is. Lead below, that means the reaction will happen. So that means the zinc and the lead are going to swap places. So we have lead. We write the 0 as a superscript or S for solid. Okay, is that reaction balanced? We got two NO3s, one lead, one zinc, one lead, and one zinc. And remember that expression, salt below goes. When I say goes, that means it happens. All right. The same reaction, what are the two half reactions? Okay, so the metal is being oxidized. So zinc plus 2, that means it's going to lose 2 electrons. And then we have to have those 2 electrons being gained back. So notice the 2 electrons on each side cancel. And these are called, again, half reactions. Okay, what does oxidation mean versus reduction? Oxidation means loss of electrons. Reduction means gaining electrons. By the way, I'll publish this as a key. I know a lot of you are taking pictures. Okay. All right, so this is a gas problem. Okay. Right away, we have initial and final conditions. That means we're going to be using the initial, final conditions. Okay, so we have initial conditions on the left. It's the volume is 12.3 liters. Pressure is and the temperature already converted for you, 345. Okay. Now notice we don't have to use R this time, only when we have the PV is equal to nRT. When we have initial final conditions, the R's cancel out. Notice we didn't mention moles either. So the ends cancel out as well. So we don't know what the final volume is. Let's use L as a variable. And we have what, 345. Okay, and we just solve for L. To solve for L, we're going to multiply both sides by 234, divide both sides by 345. Say again? Okay, so we want to isolate the L, right? Okay, so it's being multiplied by 345. The opposite of multiplication is division. So we divide both sides by 345. Yeah, or we do cross multiplication. Depends how you were taught. Okay, and because it's the L is being divided by 234, we have to multiply both sides by 234. Does that make sense? Just a minute. What now? That should be 234, not 2 point. See the 243 on the right? Okay. All done. Oh, double replacement. It's a good lab. You'll like it. I like it better than last week's lab. Goes fast too. So, all right. That's our test review. Now, are there any questions about the test? It'll be very, very similar to this. Lengthwise, yeah. Yep. I mean, it'll be like not, I could easily really make things different, but the point of a practice test is to give you an idea of how long it is, how hard it is. It won't be any harder or easier than this. Okay, and I'm going to make a copy of the screen, the key for you as well. Okay, now I want to do one more thing. I'm going to introduce you to Unit 4. I'm going to give you an idea of what Unit 4 is all about. Now, this is a very, very important unit. This and Unit 5. Unit 3 is 2, I guess, but particularly this one. This is a real weak spot for students coming into 1A, 2A, and 3A. Stoichiometry. It's a funny sounding word. Stoichiometry. And basically what it is, it relates mathematically all the parts to the balanced equation. Reactants, products, individual parts, mathematically. Now, usually they say analytically. Whenever we say analytically, we're really talking about the mathematical relationships between those. Now, this is a typical stoichiometry problem. If 34.5 grams of water is formed, how much oxygen gas was used? So now we have one extra element here. We have a chemical reaction going on. That requires one extra step. So this is a reaction here. Methane CH4 plus oxygen gas gives us carbon dioxide and water. By the way, Unit 4 is going to have a take-home problem too. I'll post that sooner than later. Hopefully tonight. I always say that and it ends up being tomorrow. But anyway. All right, so step 1 is there an equation to be balanced? Yes, balance the equation. First step, if you don't balance it correctly, you miss the rest of the problem. And these are typically worth anywhere from 12 to 15 points. So it's real important to balance that equation first. So that's what we did. And I want to remind you, a balanced equation gives us two things: molar relationships with the coefficients and molecular relationships with the coefficients. So what does that mean? Okay, that means one molecule of methane will react with 2 molecules of oxygen gas, giving us 1 carbon dioxide and 2 waters. Or 1 mole of methane reacts with 2 moles of oxygen gas, gives us 1 mole of carbon dioxide, 2 moles of water. Now, the reason why we balance the equation is we need a molar ratio between what we start with and what we end with. And that's the essence of stoichiometry. And these steps, and then we say what's given. .5 grams of water. Notice we have grams and water above it. Very important to put the water above it. Convert to moles, because balanced equations are not a mass relationship. They're a molar relationship. So the first thing you do is convert to moles using the molar mass from the periodic table. Now here's where the balanced equation comes in. The middle step. The middle step is the ratio from the balanced equation of the coefficients of given and what you're trying to calculate. So you put calculation, what we're trying to calculate, over what's given to you. Now this is the coefficients. Now what this does, this converts the moles of given to moles of calculated. So at this point here, we have moles of oxygen gas. We don't want moles, we want grams. So then we convert to grams. So I'm going to generalize this. All stoichiometry problems have three parts: a given conversion to moles, a mole-mole ratio from the balanced equation, and then what we're trying to calculate, we're going from moles to what we're trying to calculate. That's three ratios, every single one. Now, when you do the stoichiometry dry lab, you're going to notice when you look on the answer sheet, they're all going to have three parts, every single problem. Every single problem. Now, it may have four steps if you're going to convert, for example, to kilograms from grams or something like that. But the meat of the problem has three parts: given to moles, moles ratio, moles to calculated, every single one. Okay, so I wanted to introduce that to you guys, because I'm going to get into this heavy duty on Wednesday. Wasn't that fun? It's going to be mathy for the next couple of weeks, you guys. All right, remember, stoichiometry test is Monday. Following Thursday will be your final, which is mainly Unit 5. Okay.